Welcome to Beyond the Brackets. Let's take a look at integral test, a method that connects infinite series with definite integrals to analyze convergence. If for x greater than or equal to 1, f of x is a non-negative, monotonically decreasing integrable function such that f of n is equal to un for all positive integers n, then the series and the improper integral either both converge or diverge. The interpretation of this statement is f of x is defined for x greater than or equal to 1 such that it is positive, continuous and decreasing, and if un is equal to f of n, then integral test says that if the result of the improper integral is finite, then the series converges, and the result of improper integral is infinite implies the series diverges. To understand the concept better, let's solve some problems. Here we are asked to test the convergence of the given series using integral test. Here the nth term is given by 1 by n square plus 1. Replacing n with x, we define the function f of x as 1 by x square plus 1. Applying integral test, consider the integral from 1 to infinity f of x with respect to x, where f of x is 1 by x square plus 1, whose integration will be tan inverse x. Applying the limits, we get tan inverse infinity minus tan inverse 1, which is pi by 2 minus pi by 4. On simplification, we get pi by 4, which is a finite value. So, by integral test, the given series is convergent. Here a series is given where the nth term is 1 by 2n minus 1. To apply the integral test, replace n with x to get corresponding function f of x as 1 by 2x minus 1. Integral from 1 to infinity f of x with respect to x will be integral 1 to infinity 1 by 2x minus 1 with respect to x. We know that the derivative of 2x minus 1 is 2. So multiply and divide by 2 to write it in the form f dash of x by f of x, which integrates to log of f of x. Applying the limit, since the upper limit is infinity, so 2x minus 1 goes to infinity, which means log of 2x minus 1 also approaches infinity, and hence the result is infinite. So by integral test, the series is divergent. Here comes the next question where the infinite series is given. The first term is sin pi, second term is 1 by 4 into sin pi by 2, third term is 1 by 9 into sin pi by 3. So the nth term will be 1 by n square into sin pi by n. Consider the function f of x by replacing n with x, we get 1 by x square sin pi by x. Applying integral test, integral from 1 to infinity f of x with respect to x will be integral from 1 to infinity 1 by x square sin pi by x with respect to x. To integrate this, substitute pi by x is equal to t. Differentiating both sides with respect to x, we get minus pi by x square dx is equal to dt, which makes 1 by x square dx is equal to minus dt by pi. Adjusting the limits of integration, we have pi by x is equal to t. So for the lower limit x is equal to 1, t will be pi. For the upper limit x is equal to infinity, t will be equal to 0. Substituting these values, the integral becomes minus 1 by pi integral pi to 0 sin t dt. Notice that the negative sign flips the limits of integration, so we can rewrite it as 1 by pi integral 0 to pi sin t dt. Integrating this, integration of sin t will be minus cos t. Applying the limits of integration, we get minus of cos pi minus cos 0, where cos pi is minus 1 and cos 0 is 1. This simplifies to 2, which is a finite value, so the given series is convergent. Moving on to the last question, this is the infinite series given. The pattern in the numerator follows: the first term is 1, the second term is 4, the third term is 9, which means the nth term will be n square, and the denominator has 2 as the first term, 9 as the second term, 28 as the third term. So the nth term will have n cube plus 1. Consider the function f of x by replacing n with x, we get x square divided by x cube plus 1. To apply integral test, consider the integral 1 to infinity f of x with respect to x, so we get integral 1 to infinity x square by x cube plus 1 with respect to x. We know that the derivative of x cube plus 1 will be 3x square, so multiplying and dividing by 3, it is now of the form integral of f dash of x by f of x, and the value will be log of f of x, so we get log of x cube plus 1. Applying the limits to this, the answer is infinite, so the given series is divergent. This concludes our discussion on integral test. Here, some practice questions are included along with their answers.